Let's talk about one of the simplest yet most fundamental ideas in natural language processing. It's a technique called the bag of words model, and it all starts by trying to answer a very basic question.
I mean, think about it. A computer doesn't see words or sentences, it just sees a sequence of characters. It has no built-in concept of grammar or context or meaning. So how do we possibly bridge that gap? How do we take messy, unstructured text and turn it into the clean, structured numbers that a machine learning model needs? Well, we're about to break down one of the most foundational answers to that exact question.
At its core, the problem we're solving is a kind of language barrier, not between two people, but between us and our machines.
You have to remember, to a computer, a sentence like "the quick brown fox" is no different from a random string of nonsense. They're both just a list of symbols. So if we want to do anything useful, like figure out if an email is spam, we first need a way to represent the content of that text numerically. This whole process is called feature extraction, and it's our starting point today.
So how do we begin? The bag of words model offers a solution that is, well, brilliantly simple. In fact, the name itself gives you the perfect mental model for how it works.
Okay, so here's how you can picture it. First, you take a sentence. Now, and this is the most important part, you decide to completely ignore all grammar and word order. You literally just imagine tossing every single word from the sentence into a big, jumbled bag, and then you simply reach in and count how many times each unique word appears. That's it. What you're left with is a simple count for every word in that text.
And this gets to the heart of the trade-off. We lose all the rich context that comes from the sequence of words, but what we gain is a simple, numerical summary of what's inside the text. It's a radical simplification for sure, but it's also surprisingly effective.
All right, so that's the big idea. But how do we translate that analogy into a more formal process that a machine can actually use? We need to get from that messy bag of counts to a structured numerical format.
The process always starts by building a vocabulary. This is just a master list of every single unique word that appears across our entire collection of documents. Think of it like a dictionary for our specific data set. Every word gets its own unique spot, its own index.
Now, once we have that vocabulary, we can build what's called a document term matrix. It's simpler than it sounds. Each row in this matrix is one of our documents, say a movie review, and each column is one of the unique words from our vocabulary. The number in each cell? It's just the count of how many times that column's word appeared in that row's document. And just like that, we've converted every piece of text into a numerical vector. It's now in a language that a machine learning algorithm can finally understand.
A really important consequence of doing this is that we end up creating something called a sparse matrix. Because any single document is only going to use a tiny fraction of all the words in our total vocabulary. That means most of the entries in its vector will be 0. This high dimensionality and sparsity are just defining features of the bag of words representation. Okay, so this whole thing sounds really simple, maybe even a little too simple. So where is this model actually useful in the real world? Turns out it's a workhorse in a lot of classic NLP tasks. For spam detection, the sheer frequency of words like free or guarantee is a huge signal. For sentiment analysis, just counting words like amazing versus awful can get you pretty far. For these kinds of classification problems, where the presence of certain words matters more than their order, this model works surprisingly well. So why should you, as a practitioner, care about such a simple model? Because it's fast, it's efficient, and it's an incredibly cheap way to get text ready for a model. The core idea here is really powerful. Documents that have similar word counts are very likely to be about similar topics. And that simple assumption unlocks the door to using tons of standard machine learning algorithms on text data.
But of course, that beautiful simplicity comes at a price. It's crucial that we're honest about the trade-offs we're making when we choose to use this model.
Bag of words is fantastic at capturing word frequency. It gives you a great high-level signal about a document's core topic. But what it completely misses is context. The classic example is dog bites man versus man bites dog. To a bag of words model, those two sentences are identical. They have the same words with the same counts. The meaning, which is entirely locked in the word order, is just gone.
Now, to deal with some of these weaknesses, people developed more advanced techniques, like TF-IDF. It's a really clever extension that adjusts the raw word counts. It gives more weight to words that are important and unique to a document, and it downweights common words like the or is that don't carry much meaning.
So if you remember just one thing, let it be this. Bag of words is a way to turn text into numbers by just counting words.
And in doing so, it makes a very deliberate trade-off. It sacrifices context for simplicity.
And that leads us to the real takeaway. For any problem you're working on, you have to ask yourself, is sacrificing context for simplicity the right trade-off here? For something basic like spam filtering, the answer might be yes. For something complex like machine translation, it's a definite no. Understanding that choice is the key to using this tool effectively.